multiple choice questions, percentage yield. Ethanol can be made from glucose by fermentation. That's glucose, that's ethanol, it's got the OH group, that's alcohol, and that's carbon dioxide. And experiment this much percentage yield. Percentage yield is actual yield over theoretical yield times by 100. So I need to find out the moles of the actual yield of ethanol. So what I think we have to do is work out the moles of ethanol and work out the moles of glucose. So work out the moles of glucose, kilograms to grams, 1440 divided by 180, and that is give me 8. That will give me 8, and that is the theoretical yield. The actual yield of ethanol, 268 divided by 46, 5.826, keeps going, times by 100. So my answer divided by 8 times by 100, that will give me theoretical yield 72.8%, percentage yield 72.8%. Question 7. What is the percentage yield when 20 grams of aluminium are produced from this much of aluminium oxide? Percentage yield, actual yield over theoretical yield. A yield divided by T yield. So I can find out the moles of aluminium. A mole of aluminium is 27, so the moles of aluminium is 20 divided by 27. 0. Percentage yield when this much aluminium is produced by this much. So the actual yield of aluminium, 0.740747 moles, and then the moles of aluminium oxide, mass divided by aluminium, 24.1, 27, 27 plus 27 plus 16 plus 16 plus 16, and then do 0.740747 divided by my answer times by 100. No, that gives me 151%, so therefore that's not right. Percentage yield when this much of aluminium, I need to think of a logical step approach. Moles of aluminium, 20 divided by 23.1. No, 20 divided by, keep forgetting it, it's 27. 20 divided by 27. Yeah, so that's 20 over 27. Moles of aluminium equals 20 divided by 27 are produced from 50 grams of aluminium oxide. Well, if I find out the moles of aluminium oxide is 50 divided by 27 plus 27 plus 16 plus 16 plus 16, and that is my theoretical yield, but then it turns out by 2 because I want 2 to 4 mole ratio. Then I've got that, and then I do 20 divided by 27 divided by my answer times by 100. I get 76%. Okay, so I'll explain it again. Find out the moles of aluminium. That's the actual yield. To find out theoretical yield, find out the moles of aluminium oxide, and then realize 2 to 4 mole ratio, aka 1 to 2. So I just double them. I just double that. And that will give me the moles, the theoretical yield of aluminium, and then just do actual yield divided by theoretical yield times by 100. Question 3. Nitration of this produced this much of that. What is mass is produced? So I find out the moles of methyl benzoate, mass over mR, and it produces this much of methyl 3 nitrobenzoate with an mR of that. Now I want to find out the mass of that. Well, 1 to 1 molar ratio. So, okay, so I find out the moles 1.70 divided by 136.0, 1 over 80, that's for methyl benzoate. And therefore, to find out the mass of methyl 3 nitrobenzoate, moles mass of MR, mass is moles times by the MR, which is 181.0 given in the question. But I know the percentage yield is 65%. So I get 2.2625, but I need to also then times it by then what I do is I get 1.70 divided by 136 moles times by 181.0, and then I get 2.2625 as the mass produced, but then I'm given a percentage yield, so now I need to times by not 65 over 100, the opposite, 100 divided by 65, and that will give me the final answer. Answer times by 100 divided by 65. No, sorry, obviously 65 over 100. What we're doing, 2.2625 times by 65 divided by 100, 1.47. That was a tricky one, and then remembering to time by 65 or 100 at the end. This one, equation for this is ethane is that what's the mass of ethane that can be produced from this much of hydrogen. So I find out the moles of hydrogen, mass over MR, which is 2. You can clearly see it's a 1 to 2 molar ratio. Therefore, I then divide that by 2. That will give me the moles of ethane. And then I can find out the mass of ethane, but then I also need to times by 65 over 100. That's the experimental yield. So 16.20 divided by 2. Then I get 8.1. Do my answer divided by 2, 4.05 moles. Moles in mass over MR, mass is going to be moles, 4.05, times by, so 4.05 times by the MR of ethane, no, that's ethine. I'm trying to do it here. It doesn't matter because they're both 2 to 1 molar ratios for hydrogen and ethine, or hydrogen and ethane. Times by 12, but the MR does plus 12 plus 6, C2H6. That would give me 121.5 grams. But then I'm given the experimental yield, aka percentage yield. Why would I be given that? Because now I need to times it by 65 over 100. If I do my answer times by 65 over 100, I get 78.98 grams. Therefore, the answer is B. And the final one, question 9. After the reaction of some zinc metal with excess sulfuric acid, student collected this much of that. The yield was that. So I need to find out the moles. Wait. Excess sulfuric acid contains that what was the original mass of zinc used. Collected this much of crystals. The crystals of that was the original mass of zinc used. I've only got 1 zinc, so there's going to be 1 anyway. 1 to 1 molar ratio. I need to find out the moles of the crystals. 40.8 mass over the MR, which it doesn't give us, so I'm going to have to work it out. So zinc MR is Zn is looking for it. Zinc. Found it. 65.4. So 40.8 divided by 65.4 plus sulfur 32.1 plus 16 plus 16 plus 16, and I've got 7 H2O crystals plus 2 plus 16. Get the moles as 0.2495. Moles is mass over MR. Mass is moles times by the MR of zinc, which I just 65.4. And then I need to times that by 70 over 100 because that's the yield. And I get 11.424. So I did something wrong clearly. Maybe I do need to include the 7 when I'm finding out the MR. So 40.8 divided by 65.4 plus sulfur 32.1 plus 64 plus 2 hydrogen times by 7 plus 14 plus 16 plus 16 plus 16 plus 16 plus 16 plus 16 plus 16, then times by the MR of zinc 65.4, and then times by 70 over 100. Nope, still haven't got the correct answer, so I'm going to leave this one for another video. That's the end of multiple choice questions.